Okay, guys. I want to just do a video explaining the notes and kind of going through some things that I think you guys may get confused on along the way. So if you have not written down the notes from this page in your notebook, then I want you to pause the video right now until you get this written down. Remember that the only way that we can lock this in our brains is if we read it once, write it once, read it back to ourselves out loud. That way it's locked in our brain 4 different times because we're seeing it, we're hearing it, we're saying it, and we're writing it. Pause the video. Make sure you have this written down in your notebook with the date and the notes that say angles. Okay, so welcome back. We're going to dive into, I'm just going to show some different examples of when these different definitions are shown in a real world or like a real math context. The first one that I'm going to show is congruent angles. So to do that, let me come out of my screen. We're thinking about congruent angles. We're thinking about 2 angles that have the same measurement. So on this, there are a lot of different angles here. We could pretty much form an angle based on 3 different points as long as there's an angle that's formed there. So we could form an angle with angle CXD. And we know that angle CXD has a 90-degree angle because that blue box that I got right here goes from line C to line D, and it covers angle X. So that is a 90-degree angle. Another angle that is 90 degrees is angle DXE. 2 ways that we can tell. We know that that these are 2 straight lines. We could form a box right here that shows that these are 2 90-degree angles. The other way that we can tell is when angle CXD formed a 90-degree angle, angle CXE forms a straight line. And we know that a straight line is equal to 180 degrees. We learned that yesterday. And this is just half of 180 degrees. So this other half, even though it doesn't have a measurement, we know that it's the other half of 180 degrees from this straight line. If that's 90 and this entire straight line is 180 degrees, we know that D, X, and E is a congruent angle with angle C, X, and D. The next example that I want to talk about is adjacent angles. Adjacent angles, okay, just a little bit. You're not in trouble. You're doing a good job. I just need you all to be a little quieter. Oh my gosh, you guys heard me say that. Okay. Adjacent angles is the next one that I want to talk about. Adjacent angles are classified as 2 angles that share the same vertex and they share the same angle forming line. So an example of an adjacent angle would be angle CXF. Angle CXF would be adjacent to angle FXD. The reason that we can tell is because they share the same vertex or the same point of angle formation, and they share the same line that makes their ray. So we can say that angle CXF and angle FXD are adjacent angles. Another example of an adjacent angle could be angle CXF and angle GXE. The reason that we can tell is because angle CXF and angle GXE do have the same vertex at that point X. So their angles are being formed at the same point, and they're adjacent because these 2 lines, like angle CXF, is forming the same line. It's formed by the same line that angle GXE. So let me use a different color marker to show you guys. This is one line right here, and this is one line right here, and this is its vertex point. So these are adjacent angles. Okay. So every angle could have more than one adjacent angle. You have to make sure that one, it is sharing the same vertex and it is sharing the same line. The next new thing that we want to talk about are complementary angles. And complementary angles are defined as 2 angles that when you add them together equal 90 degrees. So an example of a complementary angle, if we look at angle CXB, we see that it's 32 degrees. It's 32 degrees, and it tells us that. And now we're thinking about, what does the value of angle B, X, and A, angle B, X, A, what does the value of that have to be? Well, we know that this is 32 degrees, and whatever this angle is, when you add it to 32, it has to equal 90, because angle CXA is a 90-degree angle. So we're looking at it, we could do the math and say 90 minus 32, and that would tell us that the value of angle BXA is going to be the difference between 90 and 32. So we just do that quick little math right here. 90 minus 32. Decompose that 8, 10, 8, 5. And so we know that this is 50, is a 58-degree angle. Let's see another example of a complementary angle. If we go back to the first one that we looked at, angle CXF and angle FXD, we see that angle FXD is 90 degrees, which means that the angle CXF has to be whatever amount is going to, when added to 40, gives us 90. So we know that angle CXD is 90 degrees, and if FXD is 40, then that means that CXF has to be 50 degrees. This thing is, it originally, when I was in 7th grade, it was super confusing to me when I first saw it, and then I had to start thinking about how angles are formed. Remember that angles are formed when you have 3 points, one of which, that middle point, is labeled as the vertex. So C, X is the vertex F. F, X is the vertex D. D, X is the vertex E. E, X, G, G, X, A. A, X, B. B, X, C, C, X, F. These are all different angles that are formed. They all share the same vertex though. Okay? This is going to be helpful. If you need to watch this a few times or need to go back, then absolutely do that. I am going to go on, and you're going to have a whole new video for your notes.